Hello viewers, welcome back. Today I present you Michael Walden magnet motor engine. This image over here. It's really amazing. You will see that this is basically, it works similarly to the standard car engine. But let's get to the drawings and see what Michael Walden imagined how this could work.
Hello viewers, check this out. This is the magnet motor engine by Michael Walden. So this is something which looks really interesting. As we all know, we are basically educated people, and we all know that this is the similar engine like the engine we have in our fuel, like the fuel engine. So let's start explaining one by one these components and how Michael Walden had idea to transfer and to make a similar engine which is powered by the magnet power. So let's see how this all should work. Let's start from the beginning. Okay, this will be our cylinders, and this is not, of course, like this in the air. These cylinders, this is the part of the engine block. They are not just in the air, so this is mounted like part of some engine block. Of course, this is it. So inside of the cylinders we have the pistons, so this inside, and let me hide the cylinder now and the engine block, let's say fully. Now these are the pistons. Pistons are going up and down. And how do they move? So they to move up and down, they need to be connected to the crankshaft. So this is on the bottom. This is, everybody in our car has a crankshaft. This is the special part of the steel, or I don't know which material it is, but it's designed exactly in this way, separated by 90 degrees. And on this are 4 pistons. So basically, if I select now the pistons, you will understand that crankshaft, it's the, let's say, part of the engine which transfer the circular motion, you can see it's in 4 positions, to the reciprocating motion which goes up and down. So this is how we have the fuel coming to the pistons inside of the cylinders, and then the expansion created in the cylinders creates this to go up and down in a circular motion. And of course the crankshaft is this part of the engine which transferred the circulating motion to reciprocating motion. The perfect thing which is designed, I don't know, 200 years ago. Then you can see, instead of this pistons, so these pistons, of course, in these magnet motor engines will be the magnets. They will not be just part of the aluminum or part of the, I don't know, steel. They will just be permanent magnets. And let's say polarity, it can be one or other way around. So it's not that important. And so this is so magnets, permanent magnets, will move inside of the cylinders up and down through the crankshaft. Then on the top we have another shaft on which are permanent magnets. So this will be actually our stator magnets in this case. So stator magnets, they are stationary, but they will spin. They will spin, and of course, if you can see, let's say if I select just this piston and this, you see in this position when they will repel each other. So like poles repel each other. So that's it. And now if you can imagine, so other pistons, so this will also spin, this stator magnets will spin on this shaft, and like every piston, when it comes to that it's like pole, so it will repel itself from the stator magnets on the top, and that will let's say enable that this engine spins, this engine spins. So how this will spin? So there are several ways. So basically these magnets on the top can be controlled by small motor, for example, or it can be, as I think, but it's not designed in the engine, it can be just connected with the crankshaft. So this belt, with some will be created. I think it can help with the same amount of tooths that it spins, let's say in the same way, this top and bottom shafts, crankshaft and this shaft for the stator magnets, so they can be in line. So if we have this type of mechanism, it will be in line spinning of both crankshaft and the stator magnets on their shaft. So this is how we I think it should work. It's not stated clearly in the patent, so that's how I imagine it, because these upper magnets can be controlled by the motor, for example. Yeah. And then what we have then, yeah? So you can see, so they will repel each other, so that's now clear. We will have on the bottom, we will have on the crankshaft circular motion, which is created by these magnets. So these magnets will create circular motion of the crankshaft, and the crankshaft will be our output in this case, yeah, and connected to the alternator or the energy generator, yeah. So yeah, and then we have the last part, which is this red part, and you can try to imagine what it is, yeah. So it's not that difficult. So this part should be the flywheel, yeah. So just a standard piece of steel, yeah, nothing special, piece of steel, which will retain the momentum, yeah? So it has some weight, so the flywheel has some weight. It's also we have the flywheel in the car, yeah? And it's retains some momentum, yeah? So in this case, when we, let's say, start this engine by help of the motor, yeah? And then they will repel each other, these magnets will repel each other, we will have the circular motion on the crankshaft, and then this flywheel will actually help for this not to stop somewhere in between, yeah? But it can't, because it's anyway some mechanism, I think, should be controlled in this way so that all this works, let's say, in line, yeah? So that's how I imagine it, yeah? But anyway, that's basically this flywheel. This is just a piece of round steel, will be used to retain momentum, the force. This can continue to spin, yeah. So if we have some problem, that's why we have the flywheel to continue spin the crankshaft, yeah. And then we should have some kind of output, yeah, or directly. This could be on the wheels, like we have this mechanism can be connected to the wheels, and let's say run the vehicle, yeah? And it's also in this patent, it's stated that this magnet motor engine can be used in a car, yeah? So please read in description below, you can find the link for the patent. There is various applications for which this can be used, but this is one of it, yeah? So very interesting design. I spent some time with designing of this crankshaft, but yet, yeah, it's very interesting. There is also some circular design with you can see, you can read in the patent, but this one was actually pretty interesting to me, because it's this very similar, it works very similar like in the car, because we have the cylinders and then we have the pistons moving up and down, but instead of this this magnet, which will give the magnetic power or magnetic field lines to repel the cylinders, pistons, we have the fuel coming inside of the cylinder, yeah? And that's how the expansion, the explosion is created in these cylinders, and it moves this crankshaft to spin. Basically, this is it. So viewers, thank you for watching. I hope you enjoyed this presentation. Please read the patent if you want to know more. Maybe I did some mistake in explanation, because it's always stated in each patent that for those who are skilled of art, they could understand how this works, yeah? So it's not in the patent, it's not described always everything, and the variations in this which can be used, but in this case it's like an engine. So thank you for watching. Until next video, bye bye.